So as a last example, let us take this one, 17th one. Okay, so what is given in the 17th problem? Bandwidth of a signal x of t is given to be b hertz, and we have to find bandwidth of all the signals what we see below. Okay, so first one is x of 2t. So if x of t has a bandwidth of b hertz, question is what is the bandwidth of x of 2t. So what is x of 2t here? In time domain the signal is getting compressed. So what should happen in frequency domain? That fellow should expand by the same factor. In time domain, signal is getting compressed by a factor of 2. In frequency domain, the signal should get expanded by a factor of 2. So definitely what is the bandwidth? It is 2b hertz. Okay, with the same argument. So what would be the bandwidth of x of t by 3? X of t by 3 means what? Signal is expanded in time domain. Correct? X of t by 3 means signal is expanded in time domain. So what should happen in frequency domain? In frequency domain, the Fourier transform should get compressed by a factor of 3, and hence what will happen to the bandwidth? That will be b by 3 hertz. Okay, next, so with the same argument for previous two problems, we can say that x of at will have 8 times b as the bandwidth. Why? If it is x of 2t, bandwidth is 2b hertz. If it is x of t by 3, bandwidth is b by 3 hertz. So if it is x of at, bandwidth would be ab hertz. Okay, right. So we'll take fourth example, which is x square of t. So what is the bandwidth of x square of t? Note that x square of t can be written as what? X of t multiplied with x of t. Means what? You are multiplying the signals in which domain? Time domain. So what should happen to the Fourier domain? In frequency domain, the signals Fourier transform should get convolved, and hence what will happen here? So just for understanding, so let's say x of j omega is this. Okay, so this is from minus 2 pi b. Okay, I'll draw it nicely. So this is our x of j omega. Let's assume from minus 2 pi b to plus 2 pi b. Correct? Why from minus 2 pi b to plus 2 pi b? I said bandwidth is b hertz, but when you draw it, you should say it is from minus 2 pi b to plus 2 pi b. Why? Because we are in omega domain. Okay, what is the bandwidth? It is b hertz. In omega domain, that should be 2 pi b radians per second. Okay, let's come back to this one. We want bandwidth of x square of t, which and x square of t can be written as x of t multiplied with x of t. So in frequency domain, what should happen? These fellows should get convolved. Okay, so again you're convolving the same function with itself. So what will happen to the overall Fourier transform? That fellow will exist from minus 4 pi b to plus 4 pi b, and hence what will happen here? And hence bandwidth of this signal should be how much? 2b hertz. Okay, 1 by 2 pi will come. 1 by 2 pi is multiplied with that, but scaling factor is not a matter for bandwidth. Okay, so what next? We'll take the fifth example, which is x cube of t. So this fellow is looking similar to x square of t. So means what? Your x cube of t can be written as x of t multiplied with x of t, again multiplied with x of t. So what will happen in frequency domain? X of j omega convolved with x of j omega, again convolved with x of j omega, and hence what will happen to the overall bandwidth? You will get 3b hertz. So if we generalize this result, what will be the bandwidth of x power n of t? So with the same argument, we can say that bandwidth of x power n of t is nb hertz. This is x of t multiplied with x of t multiplied with x of t, and so on up to n terms. And hence in frequency domain, x of j omega convolved with x of j omega convolved with x of j omega n times. And hence what will happen to the overall width? Overall width will become n times 2 pi b, and hence bandwidth of that signal should be nb hertz. Okay, right. Next, seventh one. So what is the bandwidth of x square of 3t? So x square of 3t can be written as what? X of 3t multiplied with x of 3t. So x of 3t means what? It is compression in time domain that corresponds to expansion in frequency domain. So what will be the Fourier transform of x of 3t? Correct. So that will be from minus 6 by b to plus 6 by b. correct? X of 3t will have Fourier transform from minus 6 pi b to plus 6 pi b, and because we are multiplying in time domain, in frequency domain, it will become convolution. So again you will get from minus 6 pi b to plus 6 pi b. This is what? This is Fourier transform of x of 3t multiplied with x of 3t. So overall function exists from where to where? Minus 12 pi b to plus 12 pi b. Some shape you will have. So you will have from minus 12 pi b to plus 12 pi b. Okay. So that is the Fourier transform of x of 3t multiplied with x of 3t. So definitely what is the bandwidth here? Bandwidth is nothing but 2 times 3b, which is equal to 6b hertz. Okay, so we can extend this result again to generalize the result. So what is that? If you want bandwidth of x power n of t, so x power n of at can be written as what? X of at multiplied with x of at, like that, n times x of at. So definitely you can see that bandwidth of this signal should be n times ab, which is equal to anb hertz. Okay, next question is, what is the bandwidth of d by dt of x of t? So what is the bandwidth of d by dt of x of t? That should be equal to how much here? Yes, so bandwidth of d by dt of x of t would be equal to j omega. We want to find the bandwidth of derivative of x of t. So to find the bandwidth of derivative of x of t, we have to go into frequency domain. And in frequency domain, what will be the Fourier transform of d by dt of x of t? That would be j omega multiplied with x of j omega. So this is our x of j omega as usual. And that fellow is multiplied with whom? X of j omega is multiplied with this fellow is j omega, correct? That is a straight line passing through origin. So if you multiply these two, the overall product exists from where to where? It exists from minus 2 pi b to plus 2 pi b, and hence what happens to the bandwidth here? So d by dt of x of t will have again b hertz as the bandwidth. So if you differentiate the signal, bandwidth is not going to change. Okay, so with the same argument, if you integrate a signal also, bandwidth is not going to change, but be careful, you have to prove this. We will take it as homework. Okay, so as a last example, let us try to find out the bandwidth of this signal, which is x square of t by 2 convolved with x cube of 2t, and this whole signal is multiplied with the sine 4 pi bt by pi t. Okay, so x square of 2t. So this fellow will have what as Fourier transform? The x square of 2t by 2. So what is that fellow's bandwidth? So let me call that as b1, which is equal to how much? This is looking like x power a or x power n of at. So that should be n a into b. So that is the bandwidth of first signal. Similarly, what is the bandwidth of second signal? Let us call that to be b2, and hence what will be the overall bandwidth there? Again with the same argument, it is n a b. Okay, so totally it is 6b, but for the term inside the square bracket, okay, so but for the term inside the square bracket, so what is the bandwidth? So let me call that to be b3. So because it is convolution in time domain, what is the bandwidth? My Fourier transform will get multiplied, so bandwidth would be minimum of these two guys. So b3 should be minimum of b and 6b, so that should be equal to b. So bandwidth of the term inside the square bracket is how much? B hertz. Okay, and that whole signal is multiplied with sine 4 pi bt by pi t. So what will be this fellow's Fourier transform? This fellow will have a rectangle from minus 4 pi b to plus 4 pi b with amplitude 1. So this signal whose bandwidth is b hertz is multiplied with sine 4 pi bt by pi t. So this is multiplication in time domain. So what happens in frequency domain? They should get convolved. Okay, so the term inside the square bracket, so it will have some shape which we don't care, and that fellow exists from where to where? minus 2 pi b to plus 2 pi b. Why? That flow's bandwidth is b hertz. So this is the Fourier transform of the term inside the square bracket, and in time domain that signal is multiplied with sine 4 pi bt by pi t. So whose Fourier transform is rectangle. So in frequency domain, what should happen? These two fellows should get convolved. So after convolution, what will happen here? We will get again some shape, but that convolution exists from where to where? Minus 2 pi b minus 4 pi b. That should be minus 6 pi b, and 2 pi b plus 4 pi b is 6 pi b. So what happens? So highest positive frequency is 6 pi b, and hence what is the bandwidth there? Bandwidth is 3b hertz. Okay, right. So in that way we can solve the problems related to bandwidth of a signal. So next let's talk about sampling theorem. Okay.